Today on 8.1, we are talking about ratio and proportion. Two words that you've probably used already in the past, right? Okay. I know for a fact that we've learned this in pre-algebra, because I used to teach pre-algebra. Okay, so I know it's in that book. Okay, and most likely you probably learned it also in middle school at some point. And I guess for some of you, pre-algebra was middle school. Okay, but at some point you've came across this before. Okay, so the first thing we need to do is first just define the word ratio. Okay, a ratio is the comparison of two quantities measured in the same units. It's a comparison of two quantities measured in the same units. Okay, quantities just meaning like the measurement that we're talking about, a number. Okay, how much? Okay. So can you put a ratio of like miles and inches as a ratio? Can you put those as a ratio? Not immediately, but could you convert them to the same measurement and then make them a ratio? Yes. Okay, you could do a conversion and get them there. And that's what we're going to do first here. Okay, so if they're different measurements, maybe it's feet and inches, feet and yards, whatever it be, if they're different measurements, we have to do some conversion to get them to be the same. Okay, so our first example, I have 12 centimeters over 4 meters. They want us to reduce this ratio. Okay. Right now they're not the same measurement, correct? Can I make them the same measurement though? Yeah. How many centimeters are in a meter? 100. Okay. Now this is where it's a little tricky and some of us aren't for sure what to do. Which one do I multiply? Austin? The 4. Okay. Now, one way, I don't know that any of you are in physics yet, okay, but you're going to learn this in physics. Okay, Mr. Shaw's going to talk about I think he calls them railroad tracks or choo-choo tracks or something. Okay, and maybe you learned them with Miss McCarville too. I'm not sure. Maybe you did a little bit with her. Okay, but you can set this up, but your labels have to be opposite each other. Okay, because our labels have to go away. So in 1 meter, there's how many centimeters? 100 centimeters. Okay, and you could keep doing this conversion. That's why he calls it railroad tracks, because you could keep going, okay, if you had to keep doing more conversions. Okay, but we don't have to. This will get us to where we want. Okay, when we do this, you can always cross-reduce and cross-cancel. Okay, so my meters cancel each other, my centimeters cancel each other, correct? Okay, so here, can I cross-reduce? Yeah, what goes into both 12 and 100? 2 does, but so does 4, right? When I reduce 12 by 4, you get 3, and 100 by 4 is 25. Now can I multiply? 3 times 1 is 3. 4 times 25 is 100. And I can't reduce that anymore, can I? Okay, so what's my reduced ratio? 3 to 100. Okay, now there's multiple ways you can write this answer. You can write this as 3 to 100, or you can write this as 3 to 100, or you can write this as 3 to 100. Okay, so how many ways can you write the same ratio? 3. And at some point, whether it's today or tomorrow, I can't remember, your assignment's going to ask for this. Okay, they're going to say write the ratio in 3 different ways. These are your three different ways. I would say 95% of the time, and if they don't tell you what way to write it, I would prefer you write it as a fraction. Okay? And the reason we're going to want to write that as a fraction is because we're going to be using this in proportions. Okay? So we're going to be using it to figure other things out. If you have these 2 ways, okay, it's a little bit harder, okay, because it just doesn't set up right. So we're going to want most things in fractions for us. Yeah, the other 2 would be like if you just had to give an answer or state a ratio, something like that, yeah. And just be aware they might give it to you in those other 2 forms also. Just be aware that they're all the same thing. Okay. Questions on that one? Okay, let's go ahead and do one more of those. I have 6 feet over 18 inches. Can I get those converted into the same units? Yeah. Now, is it going to be easier to change feet to inches or inches to feet? Austin? Feet to inches. Why is it not going to be as easy to change inches to feet? You're going to get leftover. You're going to have a decimal or fraction, right? Okay. If I change feet to inches, I'm not going to have anything left over. Okay. So when I set this up, what needs to go on top? Inches. And on bottom? So how many inches are in a foot? So there's 12 inches in 1 foot, correct? Okay. Can I reduce, Carson? Okay. My inches, my labels are gone. Okay. 18 and 12 reduced to what? What can I take out of both of those? Okay, I can take a 3, anything bigger? 6. So 18 changes to 12 changes to. Okay, can I reduce 6 and 1? No, so what I would say here, go ahead and multiply now. 6 and 2 is 12 over 3. Can I still reduce a little bit? Yeah, I get 4 to 1. Now, that's a lot easier than if I wouldn't have cross-reduced, right? Okay, if I wouldn't have cross-reduced, I'd have had 6 times 12, which is 72, over 18. Okay, that's a little bit harder to reduce in the end. Okay, do some reductions first, and it's going to be an easy reduction in the end. Okay, can I write this ratio as just the number 4? Why? Right. Our definition of a ratio was the comparison of 2 quantities. If you just write it as 4, how many quantities do you have? 1. Okay, that doesn't work. Okay, so don't do that. A ratio is always going to have 2 numbers, one on top, one on bottom. Okay? So your ratio there would be 4 to 1. Doing all right so far? We've done this before, right? Been a little while, maybe need a good refresher here. Okay, what we're going to do to use this, or the way we're going to use this, is maybe they give us an isosceles triangle. I'm going to use their letters. This is not in your book, okay? But they give me L, M, and N. So you're going to want to get this copied down since it's not in your book. Okay, and they tell me a few extra things. They tell me that the perimeter is 56 inches total. Okay, so perimeter is what? All the sides are the distance around, right? Okay, and then they also tell me that LM to MN is 5 to 4. So is it a possibility that LM is 5 units and NM is 4 units? Yeah, that'd give me a ratio of 5 to 4, right? Okay, so it's definitely possible that that's 5 and that's 4. Well, if that's 5, then so is this, right? Okay. Now, the question is, when I do the perimeter here, I get 5 and 5 is 10, and 4 is 14. Is that supposed to be what my perimeter is? No. Okay. So what we have to do, let's take a look at this. Maybe I multiply this by 2. So 5 times 2 is 10. 4 times 2 is that still a ratio of 5 to 4, 10 to 8? Yeah, when I reduce it, it is, right? Okay. Maybe I multiply it by 3 and I get 15 to 12. Would that still reduce to 5 to 4? Okay. So whatever I multiply one of these by, I have to multiply the other one by the same thing, correct? Okay. So would it be okay if I just put x's here? That's signifying that I'm multiplying them both by the same thing, correct? And obviously I have to do it to the third side as well. Okay. Now I know when I add those three sides together, whatever x equals, I know they should add up to what? 56. Okay, so we're going to do that. So I'm going to have 5x plus 5x plus 4x, which should give me my perimeter, right? If I knew what x was. So that should equal 56. Good. Okay, so what I'm doing is I'm setting up an equation here to try to figure this out. Now, some of you I know can do some of this in your head, and that's okay. That's good. Okay, I'm okay with that. Okay, but there's going to come a time where you come across a hard enough problem where you can't just do it in your head. So you have to know how to set these equations up. Okay, here I have a total of 14x, which equals 56. And to solve this, I do what? Divide by 14. Good. And I get x equals 4. Okay. Inches? Why don't I label that? That's just my variable, right? Okay. I probably wouldn't count it wrong if you did. Now, if it was degrees, I would. Okay, but with distance, probably not. Okay, but so x is 4. So Amanda, what is the length of LM? 20 what? Inches, good. And then LN must be what? 20 inches. And MN must be 16 inches. How did we get all those? I took 4 and did what? Plugged it in for x, correct? Okay. So there's my lengths. Do they all add to 56 inches? Yeah. 20 and 20 is 40 plus 16 is 56. Okay. Are labels important? Yeah, because inches is way different than miles, which is way different than yards, which is different than meters, which is different than feet, right? Okay, so be careful with your labels. You need labels if you're talking about length now. So be very careful with that. You see it, Austin? Did you get it? Okay. So that's one example. Now that's talking about side length, right? Okay, you might also run into one that's talking about angle measures. Okay, maybe they give you a triangle here, triangle ABC, and they tell you that the ratio of the angles is 3 to 4 to 8. Is it okay to write a ratio with 3 numbers? I know in the definition I put 2 quantities, but this is just multiple ratios just smashed together, right? It's 3 to 4, 4 to 8, and 3 to 8 all together in one. Okay. The problem here is that's all they tell us. Then they say find the measure of the angles. So looking at this, what else do you know about a triangle? What? Okay, so all angles added together equal 180 degrees. Okay, that's one important thing we know. Carson was getting at another one for us. Opposite? Okay, now does that have to be a right angle if it's not marked? So the longest side is always opposite the what? The biggest angle, or the largest angle. Okay, so that means that obviously this is the longest side, right? So what number needs to go in B? 8. Where do the rest go? Four goes where? How do you know 4 goes in A? It's the second longest side here. And then the width, where's 3 go? Because it's the smallest angle, right? And the smallest angle is opposite the shortest side. Okay, so I have that. Pretty similar problem, really, right? Okay. Because obviously 8 and 4 is 12 and 3 is 15. That doesn't add to 180 degrees like Travis told us. Okay, so I'm going to have to multiply by a scalar, correct? So whatever I multiply 8 by, I also have to multiply the other ones by the exact same thing. You guys agree with that? Okay. So Gavin, can you set this up for us? My angles all add to 180, right? Okay, so what do I need to do with my angles? If they add to 180. Gotta add them, right? Okay, so what's one of my angle measures? What's that one? 3x plus. What's another one? 8x plus 4x. And Gavin, when I add all three of those together, it equals what? 180 degrees. Good. Okay, because it's a triangle, right, guys? Okay, so it has to be 180 degrees. If it was a square or a rectangle or a quadrilateral, it would be 360. Good. Right here, we already talked about this. 3 and 8 and 4 is 15. So I have 15x equals 180. Divide by 15. X equals 12. Is that 12 degrees? No, that's just my variable. Okay. But can I now figure out what angle A equals? Hey, Taylor Hart, what is angle A? 48 what? Degrees. And angle B, Taylor? 96 degrees. And angle C is 36 degrees. Perfect. Okay, so we took our ratio and we used that to be able to set up our angle measures in our triangle, correct? All right. Now, one other way where you might have to use these before we move on to another topic, they might give you something like this. I have triangle QSR, and I have triangle VUT. They told me that this is 18 centimeters. This is 2 centimeters. Okay, they also told me that triangle QSR to triangle VUT is 3 to 2. They want to know what are the missing lengths. So over here I need to find UT and VT. And over here I need to find QS and QR. Any thoughts? Taylor?
Couldn't you start, because you know one of the sides, you could figure out one of the other sides?
Right. So my question for you, if that's 2, what's this? Why? Right, isn't my ratio 3 to 2? Big to small, right? 3 to 2. So if that's 2, that must be 3. This has to be 3 centimeters. So QS is 3 centimeters. Does that make sense, Taylor? Pretty obvious there, right? Up here, I should be able to figure out UT. Think you got it, Austin? Yeah. How'd you do it? Not quite. I like what you divided it by this 2. Let's divide it by this 3. So 18 divided by 3 is 6. And then let's multiply it by that 2. And 12. Okay, so UT is 12 centimeters. Now, that's kind of confusing, and there's not really any rhyme or reason as to why to do it. To find the third side, I forgot to put some markings in here. You could just use Pythagorean theorem, correct? Okay. So I'm not going to go through that. They should still come out in the ratio of 3 to 2. Okay. Now that's kind of confusing as to why we did some of those things. Okay. That's where the next thing that we're going to do comes in handy. Okay. The next thing we're going to talk about is proportions. And I know you guys have talked about proportions before in the past. A proportion is an equation which equates two ratios. An equation which equates two ratios. What is an equation? What does it mean to be an equation? How do you know if something's an equation? It has an equal sign, right? That's all it takes, correct? If it has an equal sign, it's an equation. Okay? So you might have something that looks like this, and this is just a general example they use in your book. That'd be a proportion, right? Okay, I have two ratios equal to each other. Okay, that's a proportion. Now you also got to be aware that this can also be written as B over A equals D over C. Okay, so the main thing that I want you to be aware of there is just be careful. Okay, you might not have something written the exact same way as somebody else does. Is that okay? Yeah. Yes, that's fine. Okay, you just have to make sure, and we'll talk about this a little bit later, you have to make sure they have something in common. Okay? Does anybody remember from the past, because I know you've done this before, how to solve a proportion? Yep, exactly. You cross multiply. Okay, so I have this proportion. It's 4 over x equals 5 over 7. I have to solve this. So I do exactly what Carson just told us. I cross multiply. I take 7 and I bring it to the top and I get 28. And I take x and I bring it to the top and I get 5x. Notice, did I do anything with the equal sign? No, I'm taking this 7 and I'm bringing it up and to the left. I'm taking this x and I'm bringing it up and to the right. Now what? Divide by 5 and x equals 28 fifths. Is that an acceptable answer? Sure, absolutely it is. Now there is one more we want to look at. You have to be very careful when you get one like this. I have 3 over y plus 2. Okay, so a little bit different than what we're used to. O equals 2 over y. When I cross multiply this, you need to be very careful. This is all on the bottom, right? Okay, so you need to think of this as one term. Okay, so when I cross multiply, I get what here? 3y, good. But what do I get here? Okay, don't just give me y plus 4, because that 2 needs to multiply times the y and times the 2. So it's just like Carson and McKenna said, it's 2y plus 4. And then Vincent, to solve this, I do what? Okay, get the y's on in the same side, so I need to move this over, right? So I take 3y. Careful, this is minus because I got to move it over. So I get y equals 4. Okay, just be careful. You're going to run across those. Make sure that you distribute that too. You doing okay so far? Okay, do I got a few people with a calculator? You guys are going to need a calculator for this next thing, if you're participating. Okay, so what we're going to do is I have a building. It's actually a picture of a building. There's the door. Got some windows. Okay, and this building, or the picture of it, excuse me, is 2.75 inches tall, and it's 1.875 inches wide. Okay, so maybe this is a picture of the school or something like that. The actual building is 26.25 feet wide. I want to know how tall it is. This is where we're going to use our proportions. Okay, we're going to take word problems, draw diagrams, and be able to set these things up. Okay, now you do have to be careful. When you set up your proportions, you got to make sure you're putting things together that have something in common. Okay, so there's actually a couple options here. McKenna, how would you set this up? Equals. Okay, so McKenna set this up. This would work. Okay, she took 26.25 over 1.875, do those have something in common? Yeah, they're corresponding parts, right? They're corresponding to each other. They're in the same place on different diagrams. Okay? And then she put x over 2.75. Are those corresponding parts? So do they have something in common? Yes. Okay? Anybody set it up different? Carly? Okay. Okay, so 1.875 over 2.75. Okay. Do 1.875 and 2.75 have something in common? They're on the same diagram, right? And same thing with 26.25 and x. Same diagram. Okay, so that's good. Now, remember from above, could I have flipped these or flipped these? Okay, so there's actually 4 good ways to set this up, right? There's both of these, and then there's the reciprocals of these. And there's actually more. I guess you could flip them this way too. Okay, now, what if I did this? I'm going to do this one in red, because it's going to be wrong. Okay, 2.75 over 26.25 equals 1.875 over x. Why does that not work? Yeah, what does 2.75 have in common with 26.25? Nothing. It's not on the same shape, is it? And they're not corresponding parts. Okay, so that doesn't work. And same thing here, correct? Okay. Another way that you would have to be careful, what if we took this one, okay, 26.25 over 1.875, that's good, but what if I put 2.75 over x? That one wouldn't work because I started here and went to here, and then I flipped and started here and went to there, right? Okay, just keep things in mind. You got to do everything in the same order. If you start here and go here, you need to start there and go there. Okay? So just be aware of that. Notice over here when I multiply, cross multiply, I'm taking 1.875 times x, right? Am I still doing that over here? And then I'm taking 2.75 times 26.25. Am I still doing that over here? Yeah. Okay. So someone with a calculator, because your decimals are going to be a little challenging here. I have 1.875x equals, what is this? 72.1875. Okay. And then Travis, to finish solving this, I divide by what? Good. Yeah, if you have it. 38.5. Now, this is where you got to be careful. This was in inches. This was in feet. So what's my answer in? Feet. Good. Did it matter that I had 2 different labels? No. Okay, as long as you have 2 of each, you're okay. Okay. Any questions on that lesson? I know a lot of it you kind of already knew. Okay, it's a good refresher. But is there any questions on any of that? Alright. For tomorrow, I want you guys to do, on page 461, I just want you to do 4 through 9. We don't have a lot of time left in class. I know it was a long lesson. Okay, so just do those. A few problems. Pardon? Possibly for the last one. The rest of them you shouldn't, but possibly for the last one. Yep, you might need a calculator for the last one.